Hi students, now in this lecture we will discuss about the electrochemistry, what the chapter is all about, what we have to study in this electrochemistry. See, electrochemistry is actually the branch of the chemistry which deals with the relationship between the chemical energy and the electrical energy, right, taking place in a redox reaction. We have two types of energies, chemical energy and the electrical energy, right? Now what is the relationship between the two? That is the main domain of the electrochemistry. So electrochemistry relates, it tells us how we can change the chemical energy into electrical energy and electrical energy back into chemical energy. So interconversion of the chemical energy into electrical energy and electrical energy back into chemical energy, this is what we are going to study in the electrochemistry. We have a device by which we can change the chemical energy into electrical energy, and we have devices also which convert the chemical energy into electrical energy. When you change the chemical energy into electrical energy, the device in which the chemical energy is converted into electrical energy is called as a galvanic cell, right? So the galvanic cell is the device where we change the chemical energy into electrical energy, like the cells that we have in the electronic appliances, the batteries that we use normally for the car to run, to get the ignition of our car, right? So we are generating the electricity for the ignition of the fuel in the car, and that energy is generated from the chemical reaction which is going on actually in the battery of the car. So that means we can change the chemical energy into electrical energy with the help of a galvanic cell, and you can interconvert the electrical energy back into chemical energy. There are so many devices, there are so many reactions where you find the reaction does not occur without the electricity. Suppose if you take the hydrogen, if you take the H2O, you can decompose this water molecule into hydrogen and oxygen, but the decomposition is not a spontaneous process. It cannot occur of its own. This is actually a redox reaction, but the redox reaction cannot occur of its own until and unless we don't use the electricity. So we have to use the electrical energy here to convert the hydrogen H2O into hydrogen and oxygen. And in this process we use electricity to carry out a reaction. So in other words, we are converting the electrical energy into chemical energy, because if we use this hydrogen and oxygen again, and what you get the water plus again the electricity. Very interesting here. You can again get the electricity here. Okay, so you can get from hydrogen and oxygen. The chemical reaction is spontaneous, it will occur of its own, and we have a device which we will discuss later on for this process. We call it the fuel cells. Okay, very interesting, very efficient cells, fuel cells, right? This is basically a cell in which the hydrogen and oxygen combines, forms water and electricity. But decomposition of the water into hydrogen and oxygen, that's not spontaneous. That can only occur when you use the electrical energy. So therefore we can change electrical energy back into chemical energy, and the device that we use for this process is called as electrolytic cell, right? That's called as a electrolytic cell. So that means we can say that in electrochemistry we have to study the two things. We have to study the two topics. Number one is the galvanic cell, number two is the electrolytic cell. So in electrochemical in electrochemistry, right, we are going to discuss about the two types of cells. One, the galvanic cell and the electrolytic cells. and the whole chapter is around these two cells, the galvanic cells and the electrolytic cells. Galvanic cell, it converts the chemical energy into electrical energy. The one common example is the battery that we use to run the cars, okay, to get the ignition, you know, in the engines, okay, for the combustion of the fuel. So we use the electricity there, and that electricity is generated from the chemical reactions going on in the batteries, right? The lead storage batteries that we have normally. Okay, so we can also convert electrical energy into chemical energy with the help of electrolytic cells, okay, and the process is called as electrolysis, right? Electrolysis, okay. So when you change water into hydrogen and oxygen, it is not a spontaneous process, means it will not occur of its own. We have to use the electrical energy to carry out this redox reaction, right? So we can say that electrolytic cell is a device in which electricity is used to carry out a particular reaction which otherwise is not spontaneous, right? So water we cannot decompose of its own into hydrogen and oxygen. We have to use electrical energy, only then you get hydrogen and oxygen. And then if you change the hydrogen oxygen, you know, if you react the hydrogen oxygen, you'll get the water and electricity in the fuel cells. The fuel cells we are going to discuss you know, at the end of this chapter, right, in detail way what the fuel cells are, how you get electricity. But the point here is that we can carry out a reaction which is otherwise non-spontaneous, which cannot occur of its own. So we can use electrical energy to decompose the compound here. This is a redox reaction, right? And in this process we are converting the electrical energy into chemical energy. So that gets stored into the products actually, and that's why you get the electricity and the water in the fuel cells when you combine the two gases, right? So that means in electrochemistry we have to discuss about the relationship between chemical energy and electrical energy, how chemical energy can be converted into electrical energy, and electrical energy can be converted back into electrical energy, right? So there are two main topics, galvanic cells and the electrolytic cells, that we are going to discuss in this chapter, right? So electrochemistry is about the study of electrochemical cells, and in a electrochemical cell the basic reaction which actually occurs is the redox reaction. Electrochemical cells are of two types, as we discussed. One is a galvanic cell, another is the electrolytic cell. In the galvanic cell, what do you get? We get the current, and in the electrolytic cell we require the current here, right? So these are the two opposite reactions, okay? In the galvanic cell, current is generated, electrical energy is generated from the chemical energy, and in electrolytic cells the current is required to carry out a reaction. But in both the cells, whether galvanic cell or electrolytic cell, the basic reaction which occurs is the redox reaction. That means in all the electrochemical cells, right, in all the electrochemical cells, whether it is a galvanic cell or an electrolytic cell, the basic reaction is the redox reaction. And in a redox reaction we know that there is oxidation and reduction going on. You know, oxidation is basically the loss of electron, and the reduction is the gain of electron. So that means in a redox reaction one substance gets oxidized, another gets reduced. One loses the electron, another gains, and these two things can happen hand in hand. So the oxidation is only possible when there is reduction, correct? And the electrode, actually where oxidation occurs, we call it as the anode, and the electrode where reduction occurs is called as the cathode, right? So this is actually the actual definition of the anode and cathode, right? Anode is basically the electrode where oxidation occurs, right? And the cathode is the electrode where reduction occurs, okay? And the signs, should we give the negative or the positive sign? We'll discuss that later on. In the galvanic and the electrolytic cells, the sign is different, right? But the basic definition is the same, right? What is anode? It is the electrode where oxidation occurs, and the cathode is the electrode where reduction occurs. in any redox reaction, we know there is oxidation and reduction going on. So that means one substance will act as an anode, another will act as cathode. So that means the whole chapter here is about the two cells, the galvanic cells and the electrolytic cells. Hope you got the concept. Thanks for watching the video. Bye for now.